All right. Hey, I'm Lukas from vCluster, and I'm going to show you that there's more than just single tenancy versus multi-tenancy. I'm going to try to give you 5 additional tenancy models in just 5 minutes, so let's get going. Everybody's probably familiar with single-tenant Kubernetes cluster. You take a cluster, you take another cluster, you host a tenant in each one of them, pretty straightforward. The alternative to this, and most people are familiar with this as well, is you create a shared cluster. You create namespace A and a namespace B, and you hand them out to the respective tenants. So far, so good. These two approaches have varying, benefits and downsides. Obviously, separate clusters are better isolated and give, more autonomy to the tenants. They can have their own CRDs, own Kubernetes versions, etc. But, they're also much more expensive. There's a lot of cluster sprawl out there. Lots of companies have like hundreds or even thousands of clusters. And then you look at namespaces, and that solves a lot of these problems, right? But the downside of namespaces is you're really restricting tenants. So if tenants want to install their own, Argo CD or any kind of controller or CRD, they're pretty much out of luck. What about tenants that need more than a single namespace? Lots of issues there. The nodes generally in a shared cluster, obviously shared, right? So we thought, let's solve the node problem as well as the control plane problem. We split them up in 2. We launched an open source project in 2021 called vCluster, which first addresses the control plane problem. Because if you just want to give your tenants permission to create CRDs and have multiple namespaces, etc., and keep things simple, then why don't we extend the namespace-based multi-tenancy model by effectively launching a control plane inside a container and handing that control plane out to your tenants. The pods still run on the underlying cluster and still run on these shared nodes. You can see at the bottom of the diagram, nothing has changed. But obviously, a lot of folks need more isolation, and they want to keep things even more separate on the node level. So let's focus on that for a second. Besides shared nodes, we introduced a project called vNode earlier this year at KubeCon in London. It's a really exciting product. What you can do with vNode is you can create virtual nodes. Those are not, micro VMs, nested virtualization, or any of that. They're effectively containers that wrap other containers. And those are really hardened, distroless containers, minimal attack surface. And that means, if I install the vNode runtime class into my Kubernetes cluster, it's a simple Helm install, it will automatically on each one of your Kubernetes nodes create virtual nodes to wrap the pods from the same tenant. And the hypothesis here is you can break out of a container, you can't break out of the virtual node. So the tenant feels like they got entire cluster, entire node to themselves. They got an entire control plane, entire nodes on the bottom, but it's all just virtual effectively. Obviously, you could achieve a similar effect by just labeling the nodes and enforcing a node selector. That's been around in vCluster since we launched it in 2021. It's an open source feature, just like most of vCluster. And that helps you to really say, okay, everybody gets their own set of VMs or machines, but obviously you're struggling a little bit more with utilization here and effective provisioning in real time. And if you need even more isolation, this is tricky as well because you're seeing, this is still one cluster. So CSI is still shared, CNI, the networking, right? Everything runs in the same cluster still. So how can we harden this beyond this model? We can essentially take just the control plane approach. I told you earlier we split it up in 2 problems, right? There's the separate control planes for tenants and separate nodes. We've been talking about nodes quite a bit, but if we have a control plane running inside a container, one thing we can do is we can just kubeadm join nodes into that control plane. So effectively, I now have really easy and cheap and quick control planes that I can spin up in seconds. If I want to run an HA control plane, I just set the replica number to 3, and boom, I got a HA Kubernetes cluster running inside containers. And I can manage this cluster just like I would manage any other application with GitOps, Argo CD, Flux, etc. So it's really straightforward to create containers in Kubernetes clusters this way. But node management is annoying, right? Nobody likes to upgrade nodes, provision nodes. Cloud providers make this really easy. EKS launched Auto Mode last year at reInvent. It's based on Carpenter. Azure built something similar based on Carpenter and AKS. We're bringing Carpenter essentially to any environment that runs vCluster. And as you can see, vCluster can run in a bunch of different tenancy models. So we're effectively bringing this anywhere. What happens is Carpenter is baked into vCluster. It produces so-called node claims. So it essentially says, hey, I could use this private node that should be joined in my cluster in order to launch these workloads. The question is, how does that get fulfilled? We have a component called vCluster Platform, and it effectively talks to any of these node providers to get you that node, and kubeadm join it directly on demand into these vClusters. We support pretty much anything that you can provision with Terraform and OpenTofu, so it brings it anywhere. Public cloud, private cloud, even bare metal systems like Metal as a Service. You can even write your own Terraform provider. And we support systems like NVIDIA supercomputers like the SuperPod or any BCM-backed system, as well as KubeVirt that allows you to create virtual machines on bare metal nodes in your private data centers. So a very flexible model to create dynamic nodes in pretty much any environment and even hybrid scenarios. I know this was a lot of content. Here's the overview of everything we've just seen and a little bit of a comparison. My LinkedIn is at the bottom if you want to connect with me, and we have a booth over there. Happy to chat with anyone here. Thank you.